normalization. So since this is a unit of 1, so we have introduction about the various topics in databases. So normalization will study as a separate unit, right? So in databases, normalization is very important. We'll solve at least 7 to 8 problems in normalization. You have 7 to 8 types of problems in normalization, and even gate question paper or in placements, we have questions in normalization, right? So we have different normal forms: first normal form, second normal form, 3NF, 4NF, 5NF, and so on, right? So basically normalization, it's a method used for designing a good relational database, right? So basically you have good schema design and a bad schema design. So the issues in bad schema design is that there will be a lot of repetition of storage. There will be redundancy of storage of information, and similarly there will be a lot of anomalies, right? So we have insert anomaly, deletion anomaly, and update anomaly in the case of a bad schema design. So to overcome the problem of data redundancy and anomalies, we go for this normalization. So in normalization, what we do is that we refine the schema structure of a database, right? We split the larger schema into smaller schema, or we refine the schema of a database in such a way that there is no redundancy in the relation definition, right? So there is no redundancy, and similarly there is no anomaly in the design of the database, right? So to understand the need of normalization, let us look at what can be go wrong in a bad database design, right? So the characteristics of bad database design is that repetition of information, right? So redundancy of information or repetition of information, right? So automatically it involves more storage cost and inability to represent certain information, right? So we call it as insertion anomaly. So I'll be not able to represent certain information, right? We have a simple relation. So you have a faculty table with attributes: faculty ID, name, salary, department name, building, and budget. Right. So suppose that instead of having two separate tables, instructor and department, we have a single table, faculty, that combines the information from two tables, right? So instead of having two tables, instructor and department. So instructor may have ID, name, and salary, and department has a department name, building, and budget, right? So that's what we discussed in the previous ER diagram, right? So instead of having two entities or two entities are represented by two relations, we are going to have an integrated relation with the instructor ID, name, salary, department name, building, and budget. You have a faculty table containing all the information in a single table, right? So once you have this information in the faculty table, notice that there are two rows in the faculty table that contains repeated information about the history department, specifically the department's building and budget. So the repetition of the information in our design is undesirable. So repetition information waste storage space, right? So whenever you store information about history department, right? So the department name, building name of the department, and the budget of the department is repeated in all the records, right? So we have two faculty members from history department. So the department details, the department name for history, building, and budget is repeated twice. Whereas computer science, you have three faculty members associated with computer science, three instructors associated with computer science. So the same information, right? So computer science department building is building details, the budget details is repeated, right? So there is redundancy in data storage. So any good schema design, it should avoid redundancy in data, right? So it should store only unique information it should try to avoid redundancy in data, right? So redundancy in data leads to storage cost, a lot of storage cost. So it should be eliminated. Again, for example, you want to change the budget of the department from 50,000 for history department from $50,000 to $46,800. The change must be reflected in 2 rows, in contrast with the original design, which requires an update only in a single row, right? So for example, I'm going to store the student details, student ID, name of the student, department name, building name, and contact number of the department. So what happens if the contact number of the department changes, right? So I need to update the contact number of the department for all the student records. Even if one student is left out, what happens? It returns in inconsistency of the database, right? So you have multiple copies of the data that do not agree. We call it as inconsistency, right? So similarly, whenever one has to update the budget of the history department, they have to update it across 2 records. Similarly, when you update the budget of the computer science department, I have to update it across 3 records. So even if one record is left out, what happens is that you have some inconsistency, since multiple copies of the same data, they do not agree. We call it as inconsistency. Whereas in the previous definition, you are going to store instructor details separately and department details separately. When there is going to be an update in the budget of the department, you are going to update it in only one record, right? So updating information is difficult. You need to update all the records, and even if one record is left out, it leads to inconsistency. So there is data redundancy in storage of data, right? So whenever you have a bad schema design, it leads to data redundancy in storage, and it leads to increase in storage cost, right? So let us assume that there is a new department in the institute. What happens, right? So for example, we start a new department, artificial intelligence and data science, right? A building is associated with that particular department, and the budget is also allotted, but students, they have not enrolled for the particulars, or a faculty member has not been recruited for the department. So what happens? It will not be possible for you to add some information about a new department in the relation unless you have some faculty member associated with this department, right? So this is known as insertion anomaly, right? So for example, you are going to add a new department in our institute, artificial intelligence and data science, right? So it is not possible to add a new department to this relation unless a faculty is associated with this department. So you have a department with no faculty member, it is not possible to add department details alone in this relation. And right, so inability to represent the information, right? So the issue of inability to represent certain information is there in this relation, faculty relation. Suppose we are creating a new department in the university. In the alternative design, we cannot represent directly the information concerning a department unless the department has at least one instructor at the university, right? So this faculty relation is it represents a bad schema design. So it's not possible to add a department details alone. So you have to add some values for the faculty, and then only you will be able to add values for the department. So one solution to the problem is to introduce null values, right? So you're going to create a new department with building department name, building name, and budget, and you are going to have null values for the faculty. So the null value indicates that the attribute value does not exist or it is unknown, right? So unknown value may be either missing or not known, right? So this is about normalization. So normalization will study in detail about normalization. We'll study at least 7 to 8 different types of issues in normalization, problems in normalization. We'll try to solve it. So unit 3 is about solving problems in normalization. So why do we go for normalization or schema refinement is that we'll be right. So if you have a very large relation like this, right? So this relation, faculty relation, represents both instructor relation and department relation put together. So in normalization, database normalization or a schema refinement, what we do is that we break complex tables into smaller fragments so that there is no repetition in the storage of information. There is no redundancy in the storage of information, right? And you will be able to represent the information without any anomalies, right? So we'll be able to avoid the insertion anomaly, deletion anomaly, and update anomaly. To overcome the bad schema design, we go for normalization, right? So here we have discussed something about insertion anomaly. So insertion anomaly, it is not possible to add new details about a department unless a faculty is associated with that particular department. Whereas in the previous case, right, so the previous design where we have department separately and instructor separately, it's possible to add a new department information even if no faculty member is associated with this department, right? So inability to represent the information, repetition of information is there in a relation, right? So the department details are being stored in a redundant way for different instructors, right? So there is repetition of information, there is a redundancy. So again, whenever you need to update the budget of a particular department from one value to another, it should be updated across all the records. Else, even if one record is missed out, it leads to inconsistency, right? So these are the problems in a bad schema design. So whenever we need to go for a good database design, we need to go for normalization. So normalization or a schema refinement, it helps you to avoid a redundancy in database design. So it also avoids the different types of anomalies like insertion anomaly, deletion anomaly, and update anomaly, right? So for example, here some faculty members, they leave the department. So for example, you have only one faculty member in music department, right? So the faculty member leaves the department, the entire information about the department is lost, right? So whereas in the case of the previous schema design, even if the faculty member leaves the department details will be there, right? So this is known as a deletion anomaly. So it should not happen and we should avoid it, right? So to avoid the redundancy and anomalies, we go for normalization.